Hello, my name is Vladimir Korikov, and this is the Domain-Driven Design in Practice course. In this module, we will talk about domain events. We will see when they are applicable and how to actually represent them in code. We'll discuss two different ways to work with domain events, and we'll see which of them is better and why. Now, as we have two models, one for snack machine and the other for ATM, our stakeholders decided we need a new subsystem which would be responsible for managing the devices. In the real world, a subsystem like this would probably do such tasks as settle new devices across the country, monitoring cache levels inside them, and so on. In our case, let's say it has only two requirements: keeping track of all payments made by all users of our ATMs and moving cash from snack machines to ATMs. So whenever a user withdraws cash, the system should account the sum charged from the user's bank card and show us the total balance we have so far. The second requirement is about moving the cash the snack machines accumulated to ATMs. Such functionality makes sense because snack machines produce cash, so to speak, whereas ATMs consume it. Let's see how we can implement the new requirements in our domain model. From the previous module, we know that whenever we hear such words as subsystem, it's a strong sign there is a new subdomain in the application, and there is. The new set of requirements this subsystem contains is completely different from the requirements we had previously. Let's call the new subdomain management. Following the one-to-one guideline we discussed in the previous module, we need to create a separate bounded context for it. We need a new abstraction to help us keep track of all wireless payments and transfer cash from snack machines to ATMs. The best way to find a proper abstraction is to talk to the domain expert and ask the following questions. How the payments will be accounted? Where will they go? Also, how exactly the money will flow from snack machines to ATMs? Directly, or maybe there would be a transitional point? Let's say the domain expert replies that the money charged from the user's bank cards goes to our head office's bank account. And when we need to transfer cash from a snack machine to an ATM, we don't do it directly, but rather move it to the head office first and only after that send it to the ATM. Having this information in hand, we can start implementing the new functionality. This is how the new version of the context map looks like. You can see it uses the shared kernel with the money value object, but it also relates to the other two bounded contexts. The relation between them is conformist, meaning that the management bounded context conforms to whatever model the other two bounded contexts introduce. The letter U here means the bounded context is upstream, or master in other words. The letter D means downstream, or slave. The reason why the management bounded context is conformist is because it will actively use the snack machine and ATM entities for transferring cash between them, so it makes sense to make the new bounded context dependent on the existing two. With these answers, we can see there is a separate concept the domain expert used twice, the notion of head office. It is involved in both operations, so it's a good idea to introduce an entity with the same name to our domain model. Let's implement it. I'm adding a folder for new bounded context, management, and a new class, head office. It would be a single entity aggregate. Good. There would be two properties in it. The balance property will keep track of all payments made from the user's bank cards, and the cash property will contain the cash transferred from the snack machines. Let's now look at different ways of handling our new requirements. So far so good, we have a new bounded context defined. Let's see how we can implement the first requirement, how we can track all the charges made from the user's bank cards. The first option here is to place this logic to the application service ATM view model, so basically get an instance of the head office class somehow, for example via its repository, increase the balance and save the instance after that. Although it would work in our particular case to some extent, this approach has several drawbacks. First of all, such implementation means that we are coupling the ATM view model to the head office entity. It means that we are introducing an additional dependency between the ATM and management bounded contexts. With this solution, not only management knows about ATMs, but ATM's bounded context also becomes aware of management. It's a good idea to introduce as little coupling between bounded contexts as possible, and creating bidirectional dependency here violates this guideline. The second drawback is that this approach works only until there is only a single place where the take money method is called. If, for example, we add another view model to the ATM bounded context, which would also dispense cash from an ATM entity, we will need not to forget to repeat the whole process with increasing the balance again. So basically, we will need to copy this code to that new view model. Obviously, such implementation would be error-prone due to code duplication and possible human factor. The second option is to implement this functionality in the take money method itself. Add a new parameter, head office parameter, and increase the balance by the amount with commission. While this allows us to eliminate the problem with code duplication, other problems come into play. First, we still have bidirectional coupling between the two bounded contexts, which should be avoided when possible, and second, and more important, the ATM entity now gets a responsibility which is not related to the ATM itself. It is not the job of an ATM to increase the balance of the head office. Such duty just doesn't make sense in the context of our domain. It clearly violates the single responsibility principle. So how to solve this problem? The solution here is domain events. The ATM entity should raise an event about the charges that take place when a user withdraws cash, and the management context should subscribe to those events and change the head office instance accordingly. This way, we avoid introducing a bidirectional relationship between bounded contexts and stay away from the other problems we discussed here. We will see how to implement domain events later in this module. For now, let's take a closer look at this concept. So what is a domain event? A domain event represents an event that is significant for your domain model. It's important to distinguish usual events or system events from domain events. The former refers to such things as a button click, timer tick, window closed events, and so on. In other words, they represent notions that are related to the infrastructure. Domain events, on the other hand, describe occasions which are important for our domain. For example, when we click on the Take Money button on the user interface, the click itself is a system event. Our domain doesn't care about it, just as it doesn't care about anything else on the user interface. At the same time, the domain operation which happens after the button click, namely the withdrawal operation, has a meaning for our domain. In our case, we need to account that operation and change the balance of the head office. Domain events are often used to decouple bounded contexts completely or replace a bidirectional relationship with a unidirectional one. You saw an example of it in our application. Domain events will help us to avoid making the ATM bounded context aware of the management bounded context. Along with direct calls, domain events is a technique for establishing communication between bounded contexts. Although it's the most common use case for domain events, it's not the only one. They can also be used for collaborating between entities within a single bounded context. It might be that an entity inside a bounded context should perform an action which doesn't belong to the list of its responsibilities. In this case, it would be a good idea to introduce a domain event instead and perform that action elsewhere. You saw an example previously. The head office entity should react on every withdrawal in our domain model, and instead of adding the responsibility to change the balance to the ATM entity directly, we decided to create a domain event and thus free the ATM class from that duty. This is how the domain event will look like, and this is where it will be used. You can see, instead of directly changing the balance of the head office here in the Take Money method, we create an instance of the event and raise it. We will talk about the actual techniques for raising events later in this module. For now, let's discuss best practices for defining domain events themselves. The first guideline regards to the naming conventions. As a domain event represents something that happened in the past, we should name them accordingly in the past tense. So in our case, it is balance changed event, not balance change or change balance event. Also, try to be specific about what happened, don't give generic names to your domain events. The next guideline here is that you should try to include as little data in a domain event as possible. Ideally, it should contain only the information that is needed for the external code to react on this event, nothing more. In our case, you can see we include only the delta, the sum that was charged from the user's bank card. A question that often arises when it comes to defining an event is what data structures should one use to represent that information. Can we use entities and value objects for that? For example, if we had a person entity with this structure and we need to track changes in their first, last and middle names, can we just create an event like this and include the person as a property in it? The answer is no. Doing so is generally a bad practice. The reason here is twofold. First of all, this way we almost always include more information to the domain event than needed, and that contradicts the first guideline. Secondly, with this implementation, we introduce an additional point of coupling between bounded contexts. It's basically fine if the bounded context consuming the event is connected to the bounded context which produces the event and resides on the downstream side. In such situation, the consuming bounded context has to conform to the producing bounded context anyway, meaning that it already knows about its internal structure. But it might not always be the case. It may be that two bounded contexts don't know of each other and still one of them is subscribed to the events from the other. In this case, adding a domain class, be it an entity or a value object, to a domain event adds unnecessary coupling between the bounded contexts. So the guideline here is to always represent data in domain events with primitive types only. Another frequent question is whether to include an ID of the changed entity or enclose full information about it in a domain event. The answer to this question depends on the relationship between producing and consuming bounded contexts. If the bounded contexts that are subscribed to the event already collaborate with the context which originates the event, it's fine to use IDs. The downstream bounded context will be able to query the information about the entity on receiving the event. We don't introduce any additional coupling here. At the same time, if they don't know about the bounded context producing the event, we have to enclose full data that regard to the changed fields of the entity to the event. But again, we must use primitive types to represent this data and not use the entity itself.